Every winter, the average American house leaks somewhere between 30 and 40% of its heat straight out the front door. Not through the walls, not through the attic, through the door. The moment it opens, the warm air you paid to heat rushes out and cold air rushes in. Every single time. The Amish figured out how to stop that, not recently, not with a new product or a new technology. They figured it out generations ago, and they kept building the same solution into every house, decade after decade, while the rest of us forgot it existed. I have watched this work for 80 years, and I want to show you exactly what they built and why it works so well that the houses I grew up around still hold heat today the same way they did when my father was a young man. Stay until Section 8, because that is where the geometry of this thing finally clicks, and once you see it, you will never look at a doorway the same way again. People hear the word mudroom and they picture a utility space, a place to drop your coat, kick off your shoes, maybe store a bag of dog food. That is not what the Amish built. What the old order built is something closer to what engineers today would call a thermal airlock. 2 doors, a contained space between them, a deliberate gap of air that acts as a buffer between the outside world and the heated interior of the house. The principle is simple enough that a child can understand it. You never have both doors open at the same time. When you come in from the field, you open the outer door, step into the mudroom, close the outer door behind you. Then you open the inner door and step into the house. At no point is there a direct, unobstructed path from the cold outside air to the warm inside air. That sounds obvious when you say it out loud, but look at how modern houses are built. A single front door that opens directly into a living room or a hallway. Sometimes a small vestibule, maybe 4 feet deep, with both doors practically touching. The moment someone walks through carrying groceries, both doors are open at the same time, and the thermal exchange happens instantly. The Amish mudroom is not 4 feet deep. I will get to the exact dimensions in a moment. But the key thing to understand first is that this was never just a convenience space. It was an engineering decision. It was built with the same intention as the thick stone foundation walls and the root cellar below grade, to manage temperature, not fight it. What I watched my neighbors build, house after house across 8 decades of observation, was a room that treated heat as something worth protecting. Not something to generate endlessly and let escape, something to contain. Drop a number in the comments right now. 1 if you have a mudroom in your house, 2 if you don't. I want to see how many people watching this already have some version of what I'm describing. The function is thermal. The habit is the system. And the habit was taught to every child who grew up in one of these houses. You close the first door before you open the second, every time, without exception. That discipline, repeated thousands of times across a winter, is what makes the engineering work. The size of the mudroom is not accidental. This is where I want to be specific, because the geometry matters more than most people realize. The mudrooms I grew up watching, in the Lancaster County farmhouses, in the homes along the back roads where the old order families have been building for 2 centuries. Those rooms run between 6 and 8 feet deep, measured from the outer door to the inner door. The width varies, but rarely less than 5 feet, usually closer to 7 or 8. That depth is not about storage, it is about physics. When a warm interior door opens, the warm air inside the house rises and begins to move outward. That is convection. Warm air is less dense. It moves toward cooler, denser air. In a house with a single door, that warm air goes straight outside. In a house with a mudroom of proper depth, the warm air rises into the mudroom space and is trapped there. The outer door is already closed. The warm air has nowhere to go. 6 feet of depth gives you enough air volume in that buffer space that the temperature differential between the mudroom and the main house is never dramatic. The mudroom in winter runs somewhere between 40 and 50 degrees Fahrenheit, not heated, not insulated to the same standard as the main house, but not at outdoor temperature either. It sits in between. That in-between temperature is exactly the point. When you open the inner door, you are not exchanging 68-degree house air with 0-degree outside air. You are exchanging 68-degree house air with 45-degree mudroom air. The heat loss is a fraction of what it would be otherwise. Modern builders forgot this math. They optimized for square footage, for open floor plans, for the feeling of space. The Amish optimized for what a winter actually costs you. There is one more geometric detail I want you to notice in the houses I have watched. The outer door of the mudroom almost never faces the prevailing winter wind. On most of these farms, that means the outer door faces east or south. The prevailing winter winds in the northeast come from the northwest. The Amish positioned the entry to put the house itself between the door and the wind. That is two layers of geometry working together, the airlock inside, the orientation outside. Neither one alone is as effective as both together. The inner door, the one between the mudroom and the main house, is built differently from what you find in modern construction. I want to explain why, because this detail is one that almost nobody talks about, and it matters more than the outer door does. In a modern house, interior doors are hollow core. A hollow core door is essentially a cardboard honeycomb structure sandwiched between two thin sheets of wood veneer. It weighs almost nothing. It provides almost no insulation. It stops sound poorly, and it stops cold air even more poorly. The inner mudroom door in the houses I grew up around is solid wood, usually 2 inches thick or more. In the older houses, it is the same weight and construction as an exterior door, because functionally it is an exterior door. It is the last line of defense between the heated living space and the unheated buffer zone. The threshold matters too. The old houses show thresholds fitted with care, oak or maple, planed to meet the door sweep without a gap, not sealed with foam or caulk which dries and cracks, fitted mechanically so the door itself creates the seal when it closes. I have watched these thresholds outlast 3 or 4 generations of foam weather stripping in modern houses. The mechanical fit, done right, holds for decades. There is something else about the inner door that the old order kept consistent. It swings into the house, not into the mudroom. That matters in winter. When you push a door open against a pressure differential and when the house is slightly positively pressured from a wood stove running, a door that swings inward is easier to close tightly. It seats itself. A door that swings outward into the mudroom fights the pressure and tends to leave small gaps. These are small details. But small details, repeated across every entry and exit of a winter that runs 5 months in Pennsylvania, add up to something you can measure in cords of wood. If that kind of precision hits home for you, if you've been in a house where you could feel the difference, leave a like, so I know I'm not the only one who notices these things. Here is something I have watched in these houses that I almost never see explained anywhere. The boot dryer is not a device. It is not something you plug in. It is built into the floor of the mudroom, and it has been there since the house was built. What I am describing is a pair of floor grates set into the mudroom floor close to the outer wall, connected to the warm air system of the house below. In houses with a central wood stove or furnace, the warm air that rises through the house is deliberately routed to pass beneath the mudroom floor before it reaches the main living space. The boots go over the grates. The warm air rises through the leather. By morning, boots that came in soaking wet from a day in the fields are dry. Not warm room dry, where the outside is dry but the inside still holds moisture, fully dry. Ready. I want to be specific about the placement because it is deliberate. The grates sit near the outer wall, not the inner wall. This is important. If you place the grates near the inner door, the warm air rising from them would be drawn directly into the main house every time the inner door opened. Placed near the outer wall, the warm air rises into the coldest part of the mudroom, warms that buffer zone, and helps maintain that 40 to 50 degree temperature I described earlier. The boot dryer is doing 2 jobs at once. It is drying the boots, and it is heating the mudroom from the coldest end, which means the temperature gradient across the mudroom runs from warmer near the outer wall to slightly warmer, still near the inner door. The exact gradient that minimizes heat loss when the inner door opens. This is the kind of thing that gets dismissed as coincidence until you have watched it in enough houses to see the pattern. The old order kept building the grates in the same position, house after house, for 2 centuries. That is not coincidence. That is accumulated knowledge about how warm air moves. The coat hooks are on the interior wall, not the outer wall, not the wall beside the outer door. the interior wall, the one shared with the heated part of the house. I have watched people build mudrooms and put the coat hooks wherever there was space. On the outer wall, on the side wall, wherever seemed convenient. The Amish put them on the interior wall, and they did it for a reason that becomes clear once you understand the airlock principle. A wet coat hanging on the outer wall is in the coldest part of the mudroom. It stays wet longer. It introduces more moisture into the air near the outer door. And moisture in the air near the outer door means frost. Ice on the threshold, and a harder seal to maintain. A wet coat hanging on the interior wall is in the warmest part of the mudroom. The wall behind it is the wall of the heated house. Radiant warmth comes through that wall continuously. The coat dries faster. The moisture evaporates into the mudroom air and vents out through the small gaps around the outer door rather than accumulating near the inner door. This is the entry sequence the old order practiced. Come in the outer door, close it. Hang your coat on the interior wall. Sit on the bench beneath the hooks. Pull off your boots. Place them on the grates. Open the inner door. Step inside. Close the inner door. That sequence done in that order keeps the moisture, the cold, and the mud on the outer side of the inner door every time. I have watched children in these houses do this sequence from the time they could walk. By the time they are 5 years old, it is as automatic as breathing. And that habit, maintained by every person in the household across every entry and exit of a 5-month winter, is what makes the thermal performance of the mudroom real rather than theoretical. The system only works if the sequence is followed. The Amish understood that you cannot separate the architecture from the behavior. The building and the habit are one system. Everything I have described so far, the airlock geometry, the inner door construction, the boot grates, the coat wall, these are not separate features. They are one system. Each piece reinforces the others, and we are only halfway through what the old order built into this entry. If this kind of depth is what you came here for, you know what to do. That subscribe button is right there. Because what I am about to show you next, the way the mudroom manages moisture and the reason the outer door is hung the way it is, that is where this system goes from interesting to genuinely surprising. Heat loss gets all the attention. Moisture damage is what quietly destroys a house. Every time a person comes in from outside in winter, they bring moisture with them. Wet boots, damp coats, the moisture in their breath and on their skin. In a house without a proper mudroom, all of that moisture enters the heated living space directly. It raises the interior humidity. It condenses on cold window glass. Over years and decades, it works its way into wall cavities and begins the slow process of rot. The Amish mudroom contains that moisture at the outer threshold. The wet coats hang in the mudroom. The wet boots sit in the mudroom. The moisture evaporates in the mudroom and finds its way out through the controlled ventilation the outer door provides, not into the main house. I want to be specific about the ventilation because this is a detail that gets overlooked. The outer door of the Amish mudroom is not sealed as tightly as the inner door. It is fitted well enough to stop drafts, but it allows a small, controlled exchange of air with the outside. That exchange serves a purpose. It carries the moisture from drying coats and boots outward rather than inward. The inner door is the tight seal. The outer door is the controlled vent. The mudroom sits between them as a managed transition zone. Not fully sealed, not fully open, but deliberately calibrated to move moisture in the right direction. The houses I grew up around that had proper mudrooms show almost no moisture damage at the entry threshold after 60, 80, 100 years of use. The houses without them, the ones where people came straight in from outside into the kitchen, those show the staining, the warped floorboards, the soft spots in the subfloor that tell the story of decades of unmanaged moisture. The mudroom is a moisture trap. It catches what would otherwise destroy the house slowly from the inside out. Heat loss is the bill you pay every month. Moisture damage is the bill you pay once, at the end when the repair costs more than the house is worth. The outer door of the Amish mudroom swings outward. This is not a fire code requirement. It is an engineering decision that the old order made consistently, and I have watched it work for reasons that are not immediately obvious. A door that swings outward cannot be blown open by wind pressure from outside. In a farmhouse that faces a Pennsylvania winter with northwest winds that can run 30 to 40 miles per hour across open fields, an inward swinging outer door can be forced open by wind pressure alone, especially as the weather stripping ages. An outward swinging door is pressed more tightly into its frame by that same wind. The pressure works for you instead of against you. There is a second reason. An outward swinging door, when opened, does not sweep cold air into the mudroom. When you pull an inward swinging door open from outside, the arc of the door pushes a column of cold air ahead of it, directly into the space you are entering. An outward swinging door opens away from you, and you step into the mudroom without that cold air column preceding you. This matters more than it sounds. Over a winter, the cumulative effect of not pushing cold air into the mudroom buffer zone every time someone enters keeps the average mudroom temperature measurably higher. The hinge placement on these doors is also deliberate. The top hinge is set close to the top of the door, the bottom hinge close to the bottom. That placement minimizes the torque on the frame over decades of use and keeps the door from sagging. A sagging outer door is a leaking outer door. The old order built for 50-year function, not 5-year convenience. These are the details that modern builders forgot when they standardized door installation. Standard practice today places hinges at equal intervals for ease of installation. The old practice placed them for long-term fit. The difference shows up after 20 years when the modern door has sagged and the old door still closes clean. I told you in the opening that Section 8 is where the geometry clicks. Here is what I mean. Every element I have described, the depth, the inner door placement, the boot grates near the outer wall, the coat hooks on the interior wall, the outward swinging outer door, that these are not independent features. They form a thermal gradient that runs the full depth of the mudroom. And that gradient is what makes the airlock perform far better than a simple two-door entry would on its own. Follow the air from outside to inside. Outside air is 0 degrees Fahrenheit on a hard January morning. It enters the mudroom only when the outer door opens. The outer door opens outward, so no cold air column is pushed in. The person entering steps into a mudroom that is running around 40 to 45 degrees because the boot grates near the outer wall are continuously adding warmth to that end of the space. The person closes the outer door. They are now standing in 45-degree air. They hang their coat on the interior wall, where the radiant warmth from the house helps it begin drying immediately. They remove their boots and place them on the grates. The mudroom temperature, already warmer than outside, continues to hold because the outer door is closed and the boot grates are working. They open the inner door. That inner door is separating 68-degree house air from 45-degree mudroom air. The temperature differential is 23 degrees. In a house with no mudroom, that same door opening would be separating 68-degree house air from 0-degree outside air. The differential is 68 degrees. The heat loss through a door opening is proportional to the temperature differential. A 23-degree differential loses roughly 1/3 the heat of a 68-degree differential every time, across every entry and exit of a 5-month winter. If you have ever stood in a house where the entry hall was always cold, where the floor near the front door was always a few degrees colder than the rest of the room, where the heat never seemed to reach the entryway no matter how hard the furnace ran, you were feeling the absence of this geometry. The Amish did not invent the airlock. It appears in European farmhouse design going back centuries, but the old order kept building it when American builders moved on to single-door entries and relied on insulation and furnace output to compensate. They kept building it because they were paying for their own heat, cutting their own wood, and they could not afford to throw 1/3 of it out the door every time someone came in from the barn. Be honest with yourself right now. How much heat do you think you've lost through a single-door entry this winter alone? Drop your honest guess in the comments. I read everyone. The mudroom does not stand alone. In the houses I grew up watching, it connects deliberately to the heating system of the main house, and that connection is what allows the boot grates to work as I described. The wood stove in the kitchen, or in some houses, the central parlor stove, is the heat source for the entire building. The stovepipe runs up through the ceiling. The warm air rises. In a well-designed Amish farmhouse, the floor plan channels that rising warm air through the house in a specific sequence before it reaches the outer walls. The mudroom is always on the outer edge of the plan. It is the last space the warm air reaches before it exits the building. That means the warm air that has already done its work heating the kitchen and the parlor and the upstairs rooms passes beneath the mudroom floor on its way to the eaves. The boot grates tap into that warm air stream, not the primary heat, but the secondary warmth that would otherwise be lost to the outer wall. This is what engineers today would call heat recovery. The warm air that has already heated the living spaces is recaptured at the mudroom floor before it exits the building envelope. It dries the boots, it warms the buffer zone, and then, through the controlled ventilation of the outer door, it carries the moisture from the drying coats and boots out of the building. Nothing is wasted. The heat that would have been lost to the outer wall is doing a final job, drying the gear that will be needed again tomorrow morning. I have watched this system run through winters that dropped to 20 below zero in the Lancaster valleys. The wood stove ran. The boot grates stayed warm. The mudroom held its 45 degrees, and the family inside the house stayed warm on a fraction of the wood that a comparable modern house would burn. That is not an estimate. That is 8 decades of watching neighbors split wood, stack it, and burn it. The houses with proper mudrooms consistently used less. The houses without them consistently ran out before spring. If you know someone building a house right now, or renovating one, send them this video. This is the kind of thing I wish someone had shown builders 40 years ago before the mudroom disappeared from American construction. People ask me whether any of this can be built today, on a modern house, without starting from scratch. The answer is yes, I have watched it done. And the old order, if they were advising a modern builder, would tell you the same things they have always told each other. Start with the depth, 6 feet minimum from outer door to inner door, measured in the clear. Less than that, and the buffer zone is too small to hold meaningful temperature. 8 feet is better. If you have the space, 8 feet. Orient the outer door away from your prevailing winter wind. In most of the eastern United States, that means the outer door faces east or south. If your house geometry does not allow that, build a small wind baffle, a short wing wall extending from the outer door frame on the windward side. The Amish use these on farms, where the approach required a north-facing entry. A 3-foot wing wall cuts wind pressure on the outer door dramatically. Build the inner door as an exterior door. Solid core, minimum 1 3/4 inches thick. Fit it with a proper threshold and a door sweep that makes contact. This is the thermal barrier. Do not compromise it with a hollow core interior door because it looks better from inside the house. Build the outer door to swing outward. This will require a building permit conversation in some jurisdictions because modern codes sometimes require inward swinging exterior doors for emergency egress. Know your local code. In a single-story mudroom addition, outward swinging is almost always permissible. If it is not, at minimum use a heavy solid core inward swinging door with a magnetic weather strip seal that holds tighter than standard compression weather stripping. For the boot grates, connect them to your existing forced air system if you have one. A simple floor register near the outer wall connected to a supply duct will do exactly what the old gravity warm air systems did. If you heat with a wood stove and have no duct, system, a small electric radiant panel set low on the outer wall, not a baseboard heater, a low-profile radiant panel, will warm the boot area and maintain the mudroom temperature without requiring a duct run. Put the coat hooks on the interior wall, not the outer wall, not the side wall. The interior wall, where the radiant warmth from the heated house will help dry the coats from behind. Install a simple thermometer in the mudroom. Not a smart thermostat, a simple dial thermometer. Watch what the mudroom temperature does across a winter. If it drops below 35 degrees on the coldest nights, your outer door seal needs attention. If it climbs above 55 degrees regularly, your inner door is leaking warmth from the house. The thermometer tells you what the system is doing. The old order knew this by feel. After decades in the same house, you will need the instrument until you develop the same feel. The Amish did not build the mudroom as a luxury. They built it because they were heating with wood they cut themselves, and they could not afford to waste it. That constraint produced a solution so effective that it outlived the constraint. Today, even with gas and oil and electricity available, the mudroom performs the same way it always did. The physics have not changed. 2 centuries of observation. Still working, still standing, still cutting heating bills every winter in the houses where it was built right. That is what I have watched, and I wanted you to see it too. If you have made it this far, you are the kind of person who actually wants to understand how things work, not just what to buy to make them work. That is exactly what this channel is built for. Every week, another system the old order kept building while the rest of us moved on. Subscribe, because the next one goes even deeper into the engineering that kept these houses standing and warm for 150 years. Now you know why the cold air never won in these houses. It was never a matter of more heat. It was a matter of a door that was worth closing. Thanks for watching. The end screen has more in the same world. Thanks for being here. Pick whichever video on the end screen calls to you.